Hello, everyone, and welcome back to Sustainability and Engineering. I am your host, Engineer Shahzussain Sayed, a senior mechanical engineer, and thank you for joining me again today for the CPD session number 3. In this session, we are going to talk about a topic that can make or break projects in the UAE. A topic that every engineer talks about, but very few truly understand. The topic is UAE authorities. We are going to talk about not just who they are, not just which department approves what, but more importantly, how authorities actually think. Because in UAE, engineering does not stop at calculations, it does not stop at drawings, and it definitely does not stop at the design intent. In UAE, engineering ends only when authority approves it. You may have the best design, you may have follow international standards, you may have even done it technically correct. But if your submission does not align with the authority expectations, local regulations and practical site conditions, your project will face delays, rejections, resubmissions, and unnecessary stress. And this is where many engineers struggle. Authorities are often seen as obstacle, as people who slow down projects. But the truth is, authorities are not here to stop the projects. They are here to protect life, assets, and infrastructure. They review projects from a risk, safety, and long-term operational perspective. Once you understand that mindset, everything changes. In today's session, I'll help you understand why authorities review projects the way they do, what they really look for beyond drawings, common mistakes engineers make during submissions, and how you can align your design thinking with authority expectations from the day one. So, whether you are a junior engineer, a design engineer, a site engineer, or even a project manager, this session will help you reduce rejections, save time, and deliver compliant, successful projects in UAE. Now, let's begin. Let me start with something very important. In many countries around the world, authorities come at the end of the project. Design is completed, construction is planned, and then approvals are taken. But in the UAE, the process works very differently. Here, authorities start at the beginning. They are involved from the concept stage to the design development to construction and finally to handover. And the reason is very simple. Authorities in UAE are not just checking drawings, they are protecting people, critical infrastructures, and long-term sustainability of the country. They think beyond today's project. They think about fire and life safety. They think about reliability of utilities. They think about ease of maintenance. They think about future expansion, and also they think about operation for the next 20 to 30 years. This is why a drawing can be technically correct, calculated perfectly, and still be rejected. Not because the design is wrong, but because the design is not authority coordinated. Maybe the layout conflicts with the civil infrastructure. Maybe the access is not safe for maintenance. Maybe the system does not align with local regulations, or maybe it does not follow the authority's operational philosophy. Authorities do not review drawings line by line like engineers do. They review projects from a risk perspective. They ask one simple question: what can go wrong in real life? Understanding this mindset is the first real step towards becoming a senior engineer or a best engineer in the UAE. Because senior engineers or the engineers do not just design systems. They design systems that authorities can approve, contractors can build, and operators can maintain safely. And once you design with that mindset, authority approval stops being a problem and starts becoming a process you can control. Now let's understand the full UAE authority ecosystem. One of the most important things to understand about the UAE is this. Every emirate has its own authority. Each authority has a defined scope. There are no overlaps and there are no shortcuts. Let's go emirate by emirate. So Dubai. In Dubai, electricity and water utilities are controlled by Dubai Electricity and Water Authority, also known as DEWA. DEWA is responsible for electric supply, water supply, substation and meters, utility connections. Fire and life safety approvals in Dubai come under Dubai Civil Defense. They review firefighting systems, means of escape, smoke control, life safety compliances. Drainage and sewage in Dubai are handled by Dubai Municipality Drainage and Irrigation Department. They focus on drainage networks, slope and invert levels, manholes and tie-ins. Now let's move to Abu Dhabi. In Abu Dhabi, electricity and water utilities are managed by Abu Dhabi Distribution Company, that is also known as ADDC. Fire life safety approvals are under Abu Dhabi Civil Defense. Municipal coordination, including infrastructure clearances, come under local municipalities such as Abu Dhabi City Municipality and regulation municipalities. In Sharjah, electricity, water and gas services are controlled by Sharjah Electricity, Water and Gas Authority, also known as SEWA. Fire and life safety approvals come under Sharjah Civil Defense. Drainage and sewage approvals are coordinated through Sharjah Municipality and related infrastructure departments. In Ajman, utilities are managed by Ajman Sewage for sewage and Ajman Municipality for infrastructure coordination. Electric and water services are supplied to federal and local utility frameworks and also are coordinated by EWE, Electricity and Water Services. Fire and life safety approvals are handled by Ajman Civil Defense. Al Quwain. In Al Quwain, utilities are managed by Al Quwain Electricity and Water Authority, UAQEW. Fire and life safety approvals are under Al Quwain Civil Defense. Municipality infrastructure coordination is done through Al Quwain Municipality. In Ras Al Khaimah, electricity and water services are handled by Etihad Water and Electricity, Etihad WE, that is also called as EWE. Fire and life safety approvals come under Ras Al Khaimah Civil Defense. Municipal and infrastructure approvals are coordinated with Ras Al Khaimah Municipality. In Fujairah, utilities are also managed by Etihad Water and Electricity. Fire and life safety approvals are under Fujairah Civil Defense. Municipal approvals are coordinated through Fujairah Municipality. So here the most important lesson: each emirate has its own authority, has its own regulation, has its own approval philosophy. What is approved in Dubai may be rejected in Sharjah. What works in Abu Dhabi may not work in Ras Al Khaimah. A good engineer knows standards. A senior engineer or a good engineer in UAE knows which authority to satisfy, how they think, and when to involve them. That understanding is what makes projects move smoothly, from design to approval to construction. Now let's understand the difference between how engineers think and how authorities think. This is very important. Engineers focus on design. We ask, does the system work? Is it efficient? Is it cost effective? And does it meet the client's requirements? Our thinking is, how do I make this system function properly? Authority thinks differently. They focus on risk. They ask, is this safe for the public? What happens if something fails? Can this be operated and maintained? And what is the impact on the wider network? An engineer looks at the building, an authority looks at the neighborhood, the city, and the long-term future. Engineer optimizes system. Authorities control consequences. This is why conflict happen. When engineers design in isolation, it is not because authorities are difficult. It is because they are solving a different problem. Once engineers understand this difference, coordination improves. Design becomes clearer, submissions become stronger, and approvals become faster. The goal is not to fight the authority. The goal is to align engineering intent with authority responsibilities. When that alignment happens, project moves smoothly from a design to approval to construction. And this understanding is the key milestone in becoming a professional engineer in UAE. Let's pause here and clearly understand something. When authorities review submission, they are not just checking the drawings. They are checking the entire engineering package. Authorities typically focuses on 4 core areas. First are the drawings. They check whether drawings are clear, coordinated and buildable. Drawings must reflect what will actually be constructed on site. No assumptions, no missing information. Second is calculations. Authorities want to see the engineering logic behind the drawings. They ask, are the numbers correct? Are the worst case scenario considered? Are assumptions justified? A drawing without calculations is incomplete. Third is compliance. This is where codes and regulations matter. Authority checks compliances with local regulations, authority guidelines, and applicable international standards. Compliance is not optional, and industry practice is not an excuse. Fourth is coordination. This is one of the most critical checks. Authorities look at coordination between disciplines, alignment with civil and architectural layouts, and conflicts with utilities and infrastructure. A technically correct system that clashes with another service will still be rejected. So remember this. Authorities do not review one document in isolation. They review drawings, they review calculations, and they review compliances. And they also review coordination. If one of these is weak, the approval slows down. Let's start with DEWA. In Dubai Electricity and Water Authority controls electricity, water, and district cooling coordination. And this is very important to understand. DEWA is not visual driven, DEWA is number driven. They are not impressed by beautiful drawings, they are not concerned with layouts or aesthetics. DEWA look at for one first thing: numbers. They care about electrical load calculations, they care about connected load and demand load, they care about diversity and demand factors, they care about transformer and feeder capacities, they care about water demand and peak consumption, they care about network availability and spare capacities. Their main question is very simple: can the network support this building? If the answer is no, the submission stops there. You may have perfect drawings, correct standards, proper coordination, but if your loads are wrong, nothing else matters. An undersized transformer, an unrealistic demand factor, or an incorrect water demand calculation will immediately trigger rejection. This is why DEWA submissions are calculation heavy. They expect clear load calculations, clear load schedules, consistent number across all drawings, matching values between reports and layouts, and zero contradictions. Even a small mismatch between your load schedule and your single line diagram can lead to rejection. DEWA engineers review projects from a network planning perspective. They think at a city level, not a building level. They ask, what happens if the building expands? What happens during peak summer load? What happens if multiple plots are connected at the same time? That is why accuracy is critical. When dealing with DEWA, your drawings support your calculations, not the other way around. And once your numbers are correct, clear and realistic, DEWA approval becomes predictable and manageable. Understanding this mindset is the key to smooth DEWA approvals and a major step towards thinking like a good engineer in Dubai. Now let's talk about what DEWA actually checks during a submission. First, DEWA reviews your numbers. They will carefully check your final electrical load schedule and your water demand schedule. These numbers must be final, realistic, and clearly justified. Next, they check your single line diagrams. That includes electrical power line diagrams and water supply schematics. DEWA expects the values shown on SLD to match exactly with your load schedules and calculations. Then comes diversity and demand factors. DEWA looks closely at electrical diversity factors, electrical demand factors, water demand and peak flow assumptions. If these values are unrealistic or copied without justification, the submission will not move forward. They also review transformer sizing, feeder and cable sizing, and overall network capacity. Finally, DEWA checks your metering strategy. They want to see clear location of meters, proper segregation of loads, compliance with their metering requirements. Now let's talk about major hold points. the most common reason for DEWA rejection is mismatch. Mismatch between drawings and authority forms, mismatch between load schedules and SLDs, mismatch between calculations and reported values. Another major issue is load changes after approval. Once DEWA approves your loads, they expect those numbers to remain stable. Changing loads later means resubmission, additional approvals, and project delays. The third major hold point is inconsistent demand calculations. If your demand factor changes from one document to another, DEWA will immediately flag it. This is why DEWA expects discipline and consistency. Now here is a very common mistake engineers often say: we will adjust the load later. DEWA does not like later. For DEWA, your load schedule, your single line diagram, and your authority forms must match exactly. One mismatch means rejection. This is the key lesson. Freeze your loads early. Your design may evolve, layouts may change, equipment selections may improve, but your authority numbers must remain stable. A professional engineer understands this. They lock authority loads early and design around them, not the other way around. And once you adopt this approach, DEWA approvals become faster, smoother, and far more predictable. Always remember this: DEWA approvals are not about creativity. They are about three simple things: consistency, clarity, and repeatability. Consistency means your numbers never change from one document to another. Your load schedule, your single line diagrams, your calculations, and your authority forms must all tell the same story. Clarity means your submissions is easy to understand. Clear calculations, clear assumptions, clear labeling, and clear references. If a DEWA reviewer has to guess, the answer is usually rejection. Repeatability means your design logic can be trusted. If the same building is reviewed again, the same result should appear. No surprises, no contradictions, no last-minute adjustments. This is why DEWA values process over presentation. Neat documentation, logical structure, well-coordinated drawings. Not creative layouts, not complicated explanation, just simple, clear, disciplined engineering. And here is the real impact. Following these principles can save weeks, even months on a project timeline. Because most DEWA delays do not come from bad design, they come from inconsistent number, unclear documentations, and poor coordination. When you design with consistency, clarity, and repeatability, DEWA approvals stop being stressful and start becoming predictable. This is how a professional engineer should work. Now let us move to SEWA. In Sharjah Electricity, Water and Gas Authority controls electricity, water, and most importantly gas. And this is where SEWA becomes different. SEWA is technically sound. Their engineers understand calculations, design logic, and system performance. But SEWA is also administratively very strict. This means one important thing: engineer quality alone is not enough. You can have correct calculations, proper equipment sizing, compliant design standards, and still face a rejection if your submission does not meet SEWA procedural requirements. SEWA places strong importance on correct submission formats, approved forms and templates, valid authorization letters, proper consultant and contractor credentials. If a document is missing, expired, or incorrectly filled, the technical review may not even begin. Gas approvals in particular are handled with zero tolerance. SEWA treats gas as a high-risk utility. They carefully check gas load calculations, appliances approvals, pipe material and jointing methods, ventilation and safety provisions, emergency isolation and detection. Even small administrative mistakes in gas submissions can result in full rejection. SEWA expects complete documentation, correct sequencing, clear responsibility ownership. They do not accept assumptions. They do not accept "we will submit later." When dealing with SEWA, your submission must be technically correct, administratively complete, and perfectly coordinated. Understanding this balance is critical because SEWA approvals are not delayed due to bad engineering. They are delayed due to missing paperwork and process gaps. Senior engineers or professional engineers understand this early. They treat SEWA submissions like system, not just a drawing, And once you do that, SEWA approvals become structured, predictable, and far less painful. I have personally seen perfect drawings held back for weeks, not days, weeks. And the drawings were not wrong. So why does this happen? To understand that, we need to understand what SEWA actually looks for in a submission. With Sharjah Electricity, Water and Gas Authority, technical review and administrative review go hand in hand. SEWA starts with documentation before they even focus on engineering. They check whether the submission is procedurally complete. SEWA typically checks undertaking letters, and in that, correct formats, valid dates, proper project references are very important. Client stamps and signature comes next. In that, the client stamp and signatures on drawings, on forms, or undertakings are very important. Contractor authorization letters. In this, valid and contractor authorization letters, approved authorization letters matching the submitted scope are very important. Matching drawings and forms, that means same project number, same plot number, same revision status. Okay. If any one of these items is missing or incorrect, the submission stops. Now let's talk about major hold points. The most common issue is missing or outdated undertaking letters. Even a technically correct submission will be rejected if the undertaking is expired or not in SEWA's latest format. Another major issue is incorrect client signatures. Wrong signatory, missing stamps, signature not matching records. SEWA does not compromise on this. The third major hold point is inconsistent document references. Different drawing numbers, different revision codes, different project titles. To SEWA, this indicates a lack of control, and lack of control means risks. This is why in Sharjah, documentation discipline is just as important as design accuracy. Good engineering gets your design ready, but good documentation gets you approval. Senior engineers or professional engineers understand this early. They do not treat SEWA submission as just drawings. They treat them as formal contractual records. And once you respect that process, SEWA approvals become smoother, faster, and far more predictable. Gas approvals are critical. In Sharjah Electricity, Water and Gas Authority treats gas systems very differently from electricity and water. And rightly so. Gas is not just another utility. Gas is a life and safety system. This is why SEWA looks very closely at ventilation, zoning, and route safety. They carefully review gas pipe routing through buildings, separation from electrical and ignition sources, ventilation of gas rooms and shafts, zoning of gas lines and shut-off areas, emergency isolation valve locations. One coordination error, just one, can stop the entire project. A pipe passing through the wrong space, a valve located in an inaccessible area, a ventilation opening not properly sized. These are not minor comments, these are stop comments. SEWA engineers review gas systems with one question in mind: what happens if something goes wrong? They assume worst case leakage, worst case occupancy, worst case human error. That is why they are strict. That is why they do not accept shortcuts. This is the mindset every engineer must adopt. Always treat gas as a life safety system, because it is. Not just during authority submission, not just during approval, but during design, coordination, and site execution too. And here's the most important principle. Always design gas systems as if your own family is inside the building. If you would not accept that routing, the valve location, or the ventilation strategy for your own home, then it is not acceptable for any project. This mindset is what separates a drawing engineer or a draftsman from a responsible professional. And this is exactly what SEWA expects from an engineer working in Sharjah. Now we come to Dubai Civil Defense. This is where engineering becomes serious. In Dubai Civil Defense is responsible for fire and life safety. And for DCD, there is only one priority: saving lives. Everything they review, everything they question, and everything they approve comes back to this single objective: DCD is not concerned with cost savings. They are not connected with convenience. They are not concerned with convenience. They are not concerned with shortcuts. They are concerned with what happens when things go wrong. They ask, can people escape safely? Can fire be detected early? Can it be controlled or contained? And can firefighter access the building safely? DCD reviews systems such as fire alarm and detection, firefighting and suppression, smoke control and ventilation, staircase pressurization, emergency lighting and exit signage. They review buildings as if a real emergency will happen one day, because statistically it will. That is why DCD is strict. That is why DCD is detailed, and that is why DCD does not compromise. A system that almost complies does not comply. A solution that worked on another project may still be rejected if it does not suit the building. With DCD, engineering is not theoretical. It is practical, human, and time critical. And this is the mindset engineers must adapt. You are not designing for approval, you are designing for a moment when someone's life depends on it. Understanding this is the foundation of fire life safety engineering in the UAE. Now let's talk about what Dubai Civil Defense actually checks. With Dubai Civil Defense, drawings alone are not enough. DCD starts with engineering logic. The first thing they look for is hydraulic calculations. They want to see flow rates, pressure losses, critical path analysis, worst case demand scenarios. If hydraulic calculations are missing or not clearly justified, the submission stops. Next, they check pump redundancy. DCD does not accept single point failure. They expect duty and standby fire pumps, reliable changeover, compliance with failure scenarios. Then they review power failure scenarios. They ask, what happens if normal power fails? Is there emergency power backup? Is the system still operational during fire? If the system depends on power without backup, it is not acceptable. Smoke control is another critical review point. DCD carefully reviews smoke exhaust logic, staircase pressurization, smoke spread scenarios, interface with fire alarm systems. They also focus heavily on evacuation safety. They want to know, can occupants escape safely? Are escape routes protected? Is visibility maintained during fire? Now let's talk about major hold points of DCD. The most common issue is missing calculations. A fire drawing without calculation is not a design. Another major issue is single point failure. One pump, one power source, one fan. DCD does not accept this. The third major issue is unjustified assumptions. Statements like this should be sufficient, typically accepted, work in another project are not acceptable by DCD. DCD want answers. They ask you, what if power fails? What if one pump fails? What if smoke spreads to escape routes? If your design cannot really answer these questions, approval will not come. DCD approvals are not about compliance on paper. They are about survivability in real life. And that is why fire and life safety engineering demands discipline, logic, and absolute responsibility. Always remember this. Design fire systems as if you are the firefighter entering the building. This single mindset changes everything. When you are thinking like a firefighter, you stop designing on paper and start designing for reality. You ask different questions. Can I access the building quickly? Can I locate the fire without confusion? Is water pressure reliable when I need it the most? Are valves and pumps easy to find and operate? You start thinking about clear fire access routes, logical hose reel and fire hydrant coverage, visible and readable signage, safe smoke-free staircase, reliable communication and control. Firefighters do not have time to search for systems. They do not have time to interpret drawings. Everything must be intuitive, accessible, and reliable. This is why Dubai Civil Defense expects fire systems to be designed for use, not just approval. A system that looks good on drawings but fails in emergency has no value. When you design as a firefighter, your layouts become simpler, your systems becomes clearer, your coordination improves, and most importantly, your building becomes safer. This mindset is what separates a code follower from life safety engineer. And once you design this way, DCD approvals become a natural outcome, not a struggle. Now let's talk about the most ignored authority in many projects, DACC. In Dubai, drainage approvals are handled by the Dubai Municipality Drainage and Irrigation Department, commonly referred to as DACC or DM. Drainage is different from every other systems. Drainage is silent. It does not make noise, it does not consume power, it does not show alarms. But when drainage fails, everything stops. Flooding, backflow, health hazards, structural damage, and that is why municipality is strict. Municipality engineers do not review drainage as a convenience system. They review it as a permanent underground infrastructure. Once installed, drainage systems are extremely difficult and expensive to correct. That is why municipality engineer focuses on slopes, invert levels, gravity flow, hydraulic capacity, connection points to the public networks. They are not interested in assumptions. They are not interested in it should work. They want proof. Drainage must work without pumps, without power, without human intervention. Municipality always thinks long term. They ask, will this system work after 10 years? What happens during heavy rainfall? What happens if downstream level rises? Can maintenance be done safely? This is why drainage is often the last approval but the hardest to fix. Many projects face delays not because of bad design but because of drainage coordination was taken lightly. The lesson is simple. Drainage is quiet until the day it fails. And when it fails, it affects everyone. Professional engineers respect municipality early. They lock levels early, they coordinate with roads and utilities early, they treat drainage as a critical system, not a background service. And this mindset prevents costly redesign, site rework, and long approval delays. Now let's look at what DACC or DM actually checks. In Dubai, drainage approvals are reviewed by Dubai Municipality Drainage and Irrigation Department. And for DM or DACC, levels are everything. The first thing they check is invert levels. They want to see accurate upstream and downstream inverts, proper depth of cover, logical gravity flow. If invert levels are assumed or copied without verification, the submission stops. Next, they check is pipe sizing and slopes. Drainage must work by gravity, not hoop. Drainage authority ensures minimum allowable slopes are met, self-cleansing velocities are achieved, and no flat or negative gradient exists. Then come manhole spacing. They verify maximum spacing limits, access for maintenance, and alignment changes and junctions. Manholes are not optional, they are maintenance points. Drainage authority also checks time levels. This is critical. They compare proposed levels, existing municipal network levels, approved infrastructure drawing. If your time level in the drawing does not match the actual site condition, approval will not be granted. Now let's talk about major hold points for drainage and drainage authority. The most common issue is assumed invert levels. Drainage does not accept assumptions ever. The second major issue is site to drawing mismatch. What is drawn must match what exists at site. Survey errors here lead to redesign delays and costly reworks. So the third major issue is construction stage deviations. A small change on site, raising a manhole, changing a slope, or shifting alignment can completely break the system. And DM or DACC will catch it during inspection or testing. This leads to a very important rule. Never assume invert levels. Always verify. Survey, confirm, and coordinate. These are 3 key points to verify the invert levels. Okay, and then drainage mistakes usually are expensive, they are time consuming and extremely visible when they go wrong. Once a drainage system fails, it fails publicly through flooding, backflow and damage. Professional engineer understands this. They treat drainage as a fixed constraint, not a flexible design element. And that discipline is what keeps project moving smoothly through the authority approvals. Now let's move to ADDC. In Abu Dhabi, utility services are handled by Abu Dhabi Distribution Company. Abu Dhabi authorities follow a very structured and disciplined approach. Their thinking is long-term, sustainability-driven, system-oriented. They do not look at projects as a standalone buildings. They look at them as part of a city-wide infrastructure network. ADDC focuses strongly on long-term network reliability, energy efficiency, water conservation, and operational sustainability. Their first question is not, will this work today? Their question is, will this work reliably for over the next 25 to 30 years? This is why Abu Dhabi authorities expect clear planning, accurate forecasting, and future-proof design. They carefully review electrical and water demand projections, load growth assumptions, equipment efficiency, and spare capacity and redundancy. They are very particular about phasing of developments, future expansion provisions, alignment with Abu Dhabi sustainability goals. Another key difference is process discipline. Abu Dhabi approvals follow clear workflows, defined submission stages, structured reviews. Skipping steps or rushing submissions usually lead to delays. ADDC expects the engineer to plan early, coordinate thoroughly, and submit complete, well-thought-out packages. In Abu Dhabi, speed does not come from shortcuts. Speed comes from good planning. Professional engineers understand this. They treat ADDC submissions as a part of long-term infrastructure strategy, not just a project requirement. And once you align your design thinking with that mindset, Abu Dhabi approvals become logical, predictable, and very professional. Now let's talk about what ADDC typically checks. With Abu Dhabi Distribution Company, the review is very structured and concept focused. First, they check demand accuracy. They want realistic numbers for electrical demand, water demand, peak assumptions, and diversity logic. If your demand is underestimated, the network planning becomes wrong. If your demand is exaggerated, it creates unnecessary cost and capacity issues. So ADDC expects numbers that are accurate and defendable. Second, they check your redundancy philosophy. They want to know what is your reliability strategy, where do you provide standby capacity, and what happens with the when a critical component fails. They look for systems that can operate safely even during faults or maintenance. Third, they check is future expansion. Abu Dhabi projects often evolve, so ADDC wants clarity on planned future load growth, space provisions for future equipment, expandability of networks and risers, logical phasing strategy. Fourth, they check is sustainability alignment. They look beyond compliance. They look for efficient system selection, reduced energy and water wastage, long-term operational performance, and decisions that make sense over the life cycle. Now let's talk about the major hold points. The first big issue is frequent revisions. ADDC does not like constant changes after submission because every change affects network planning, capacity allocations, and downstream approvals. The second hold point is incomplete concept design. If your concept stage is unclear, if load strategy or planning are not mature, the review becomes difficult and the approval slows down. The third hold point is poor life cycle justification. If your design choices are not explained in a long-term logic, efficiency, maintenance, and reliability, ADDC will push back. And this brings us to their philosophy. It's simple. Design once, design right. ADDC prefers clarity at concept stage. They want you to think deeply, coordinate early, finalize your core strategy, and then submit. They don't like submit now, correct later. So the best approach with ADDC is think properly once, freeze the concept, then submit with confidence. Because in Abu Dhabi, speed comes from good planning, not from frequent submissions. Always remember this. In UAE, authorities are involved throughout the project lifecycle, not just at the end. They are involved at concept stage, during design development, through construction, and up to testing and handover. This is why authority coordination cannot be treated as final step. It must start early. When coordination is delayed, project face rework, resubmissions, delays, and unnecessary costs. Early coordination allows you to align design strategy with authority expectations, lock key parameters early, identify risks before they become problems. Authorities do not want to stop projects. They want projects to be safe, be reliable, be sustainable, and be maintainable. But they can only do that if they are involved at the right time. Professional engineers understand this. They do not wait for the final drawings to think about approvals. They ask authority-driven questions from day one. They design with approval logic, compliance strategy, and lifecycle thinking. This approach changes everything. Design becomes smoother, approvals become predictable, projects move faster. So the key message is simple. In the UAE, authority coordination is not a checkpoint. It's a continuous process, and starting that process early is one of the strongest skills an engineer can develop here. Most authority rejections do not happen because of poor engineering. They happen because of process failures. In the UAE, the most common reasons for rejections are mismatched documents, late changes, poor coordination, bad calculations or wrong standards. So let us go through this one by one. Mismatched documents. When drawings, calculations, authority forms and schedules do not match exactly, reviewers lose confidence. Even small inconsistencies signal poor control. The second major reason is late changes. Changing loads, layouts, or system strategies after submission creates confusion and risks. Authorities plan networks, capacity, and safety systems based on what you submit. Frequent changes break that logic. The third major reason is poor coordination. Mechanical, electrical, civil, and architectural systems must work together. When one discipline changes without informing the others, approvals stop. And here is the key truth. It is rarely about bad calculations or wrong standards. It's about documents not matching, decisions made too late, teams not coordinating. Those are the common mistakes. Good engineers know how to design. Senior engineers know how to submit. They control information, they lock key decisions early, they coordinate across disciplines. When you fix the process, approvals follow naturally. So remember this. Major rejections are not a reflection of your engineering skill. They are a reflection of your coordination discipline. And once you master that, authority approvals become predictable, manageable, and far less stressful. Authorities are not obstacles. They are partners in public safety. This is an important mindset shift every engineer must make when working in the UAE. Authorities are not here to slow down projects. They are not here to reject work unnecessarily. They are here to protect human life, safeguard infrastructure, ensure long-term reliability, and maintain public trust. When engineers treat authorities as barriers, communication breaks down. But when engineers treat authority as partners, everything changes. Design decisions become clearer, submissions become stronger, approvals become faster. Because both engineers and authorities want the same outcome: a project that is safe, reliable, compliant, and sustainable. When engineers understand how authorities think, what they prioritize, and what risk they are managing, coordination improves naturally. Questions are asked early, issues are resolved before submission, and rejections reduce dramatically. And that is when project moves faster. Not because standards were relaxed, not because shortcuts were taken, but because the process was respected. This is the mindset of a good engineer in the UAE, Respect the authority, understand their role, work with them, not against them. And when you do that, authority approvals stop being a problem and start becoming part of a smooth professional workflow. Now let's talk about the key takeaways from this session. I would like to say that to grow in the UAE, you must master authority engineering. Technical skill is important. Your calculations, your drawings, and your knowledge of standards are what get you hired. But in the UAE, technical skill alone is not enough. What truly differentiates engineers in the authority is their authority knowledge. Knowing which authority is involved, when to coordinate, and what to expect, and how they think. This is what turns a good engineer into a senior engineer. Junior engineer focuses on design. Senior engineer focuses on approval strategy, coordination, discipline, life cycle thinking. They design with authority requirements in mind from day one. They reduce rework, they prevent delays, they protect project timelines. That is why authority knowledge is so valuable in UAE market. Your technical skill opens the door. Your authority understanding moves you up the ladder. So if you want to grow faster, deliver better projects and build a strong reputation, invest time in understanding authorities. Because in the UAE, authority engineering is not optional. It's a core professional skill. And mastering it is one of the strongest steps you can take in your career. Thank you for staying with me till the end. I truly hope you found this CPD session helpful, practical, and informative. My goal with sustainability and engineering is simple: to share real-world engineering knowledge to help engineers understand not just how to design, but how to design responsibly. If this session added value to you, please take a moment to support the channel, like the video, share it with your fellow engineers, and subscribe to stay updated with future CPD sessions. Every like, every share, and every subscription helps this knowledge to reach more engineers. Because knowledge does not grow when it's kept to ourselves. It grows when it's shared. And as engineers, we carry a responsibility. Because knowledge sharps responsible engineers. And through responsible engineers, we build a better tomorrow. Thank you once again for your time and support. I'll see you in the next session of Sustainability and Engineering.